Confused about eclipses? Watch this primer from NASA explaining how lunar and solar eclipses work, why they occur, and when and where you can see them.
Futurism. Entering the future.
A solar eclipse occurs when the moon moves between the Earth and the Sun, blocks the Sun's light, and casts a shadow on the Earth. When the moon completely covers the bright disk of the Sun, that's a total solar eclipse, and it happens roughly every year and a half somewhere on Earth. A partial solar eclipse is more common, happening at least twice a year. A lunar eclipse, on the other hand, is where the moon moves behind the Earth, so it's now the Earth blocking the Sun's light on the moon, creating a shadow on it with a red tint. The easy way to remember the difference is to remember what gets darker. With the solar eclipse, the Sun gets darker, and during a lunar eclipse, the moon does. A solar eclipse is a rare event that not many get to see, because the moon's shadow is relatively small. This limits the locations on Earth that get to see it. You have to be on the sunny side of the planet, and you have to be in the path of the moon's shadow. So, if you find your area in the path of totality one year, you've hit the jackpot, because on average, that same spot on Earth will only get to see a solar eclipse every 375 years. During a solar eclipse, the moon casts a shadow with two parts, the umbra and penumbra. The moon's umbra is part of the moon's shadow where the entire Sun is blocked by the moon. In space, it's a cone extending some 400,000 kilometers behind the moon. It's when the small end of this cone hits the Earth that we experience a total solar eclipse. Most eclipse maps depicting the path will show you a circle representing the shadow of the moon, but in actuality, the true shape of the umbra is more like an irregular polygon with slightly curved edges. This is because the moon isn't a perfect circle. It has mountains and valleys on its surface, which all affect the passing sunlight and subsequent shape of its shadow. And scientists now have a greater understanding of the shape of the moon's surface, thanks to NASA's Lunar Reconnaissance Orbiter. The unprecedented level of detail from the topographic maps, photos, and other datasets has allowed us to more precisely pinpoint the regions on Earth falling within the path of totality of a solar eclipse. So, if you get the chance to witness a solar eclipse, always remember that our little moon plays a role that's quite large.